All right, here we go. We have two warm-up problems, and this is actually using the square roots that we are trying to memorize. Again, you're specifically trying to memorize your table of squares, table of cubes, so that you can help you use your roots. Now, instead of just a basic question like the square root of 25, we have essentially multiple roots that we have to work with, and we have to either add or subtract to hopefully find a final answer. So once you have it written down, you're just going to go ahead and read left to right, and you're going to do each root. When you get to the far right, you're going to notice that it has a 2 in front of it, and we'll talk about that in just a moment. All right, so if you're going left to right, we have the square root of 25, and below that, I simply want you to write down what the square root is. So what do I write? Nice, 5. Then I've got a subtraction sign. We can think about it as the opposite of addition, which of course is subtraction. And then just like we've been trying to use consistently, because it's the most common one, what is the cube root of 8? 2. Then we've got an addition sign. Now on this one here, the way that we read it is twice the square root of 49. Or you can say 2 times, because that's really what twice is, right? Twice the square root of 49. So what's the square root of 49? And twice that is 14. So go ahead and find your answer. So in other words, if you have a number in front of your root like this, it just basically means do a little bit of multiplication. So again, twice the square root of 49, twice of 7, or 2 times 7 is 14. All right, so what's our answer going to be? 5 subtract 2, add 14. Nice, simple 17. So again, it's just using the roots that you're already working with, but in the form of your basic operations that you learned in elementary school. Addition, subtraction, multiplication, and maybe even division later on. All right, write down your second warm-up problem. Again, when you have the number in the front with a 3, again, that's 3 multiplied, kind of like 3x, which is 3 multiplied by the value of x. All right, so I have 3 multiplied by the cube root of 125. So again, what's the cube root of 125? 5, so 3 times 5 is 15. Subtract. 7 times the square root of 16. What's the square root of 16? 4. So 7 times 4 is 28. We subtract. Is it positive or negative answer? Negative 13. Beautiful. So again, the only difference on those little problems there is you're using the roots and then you're combining the results using basic addition, subtraction, a little bit of multiplication, and so on. All right, so we'll keep practicing those for the next few days to get you ready for your quiz on Wednesday. All right, here is our main lesson. So we're continuing our 7.2, but this time instead of working with our perfect squares, we have what we call non-perfect squares, which means we don't know what the square root is right away, so we have to use a little bit of our 7th grade skills. Later on, I think maybe next week, towards the end of the week, I'll teach you how to find a decimal answer for the square root. But today, we're going to go ahead and try and just simplify our root. This is a very important skill for your 9th grade math, but the key is you're using 7th grade skills to do it. So before we discuss that, meaning actually we're going to do 4 actual problems from your assignment. So I just want them to be in your notes. And then when you get the assignment, you can cross them off. Gives you a little bit more time to complete them. All right. So before we do that, I need you to write down those words, prime numbers, and then take a moment and write down what prime numbers you remember. First of all, what are prime numbers, and which ones do you remember? All right, I'll give you about 30, 45 seconds. All right, so some of you had it, others just kind of waiting. So first of all, you need to know what a prime number is. Remember, a prime number is if you have two of your numbers that you are going to be multiplying and you get that new answer. Those two numbers are called your factors. A prime number only has two factors. So for example, 1 doesn't work because that's really just 1 in itself. But a prime number of 2, good. What's the next prime number? 3, because it's only 1 times 3 to give you 3. But what about 4? Will 4 be a prime number? 1 times 4 works, but also 2 times 2 works. So that's why 4 is not a prime number. All right, so what comes after 3 then? 5. Does 6 work? No. So what can we say about our even numbers? Will the even numbers work? Only the 2. 4, 6, 8, and so on, those aren't going to work anymore. So after the 2, you're really only looking for odds, but not all the odds. So we said 5, yes. What about 7? Yes. What about 9? So even though 9 is an odd number, it doesn't work because 9 can also be 3 times 3. So we good there? All right, let me give you about 20 more seconds to go through the process, find a few more. We don't have to know all of our prime numbers, but if we know several of them, it's going to make life easier on our problems. So we said 9, no 10. I heard 11, yes. We already said no to even, so I don't even have to think about 12, so 13 is good. What about 15, though? No, because 15 is going to be 3 times 5. 17. 19. What about 21? No, because 21 is 3 times 7. 23? Yeah. 25? 27? No, because that is 3 times 9. We skipped one, though. 27, go to 29. And we'll do just one more. 31? Yeah. All right, so we could keep going. You could keep listing more and more, but I don't think we need all of them. I think this is good enough. In fact, I really think that probably up to 17 or 19 is good enough for our actual problems. But again, you can keep listing them out as needed. So what we're going to do right now is I'm going to give you a number that we need to find the square root. It's a non-perfect square, which means it's not a simple like square root of 25. It might be the square root of 24 or something like that. So here we go. So it's asking us to find the square root of 88. This is not a perfect square. It's not on our table of squares. What we're going to be doing is working with what we call our factor tree. So write down the problem. So if you remember from 7th grade, using your factor tree to help you find your prime numbers, at that time you did what was called prime factorization. We're not going to do the actual prime factorization part, but we are going to search for our prime numbers. So there are several different ways that you could always start the problem depending on the size. One of the easiest way that I like with an 88 is 8 multiplied by 11. Those are two factors that will give me 88. The way that I ask my students to do it is to circle any of the prime numbers that we just discussed. And the reason we circle our prime numbers is because I know that I cannot break them up into more branches. The students who do not circle their prime numbers end up using too many of the numbers, and then they get the incorrect answer. All right, so since 8 is not a prime, I need to break it up further into additional factors. So I could write it as 2 and 4, or what can I write it as? 4 and 2. Does the order really matter? No, because it's the same thing. So 2 and 4, or 4 and 2. Which one am I going to circle? The 2, which is our prime, which tells me that I need to go ahead and find my factors of 4, which of course are 2 and 2. All right, we okay so far? Beautiful. Now, prime factorization from 7th grade, again, you'd have said, oh, I've got 1, 2, 3 of them. So you would say 2 to the 3rd power multiplied by, I've got in a single 11, so I put my 11 there. That's 7th grade. I'm not asking you to do that, but that's a good skill to still have. What I'm asking you to do, again, is to simplify the square root of 88, which means we're probably going to have a portion that's going to look something like this, where you're going to have a number in the front and then a number inside. The number inside of the root symbol, you won't know what that square root is. So that's simplifying it. So what we want to do is we want to look for our pairs, our matches. Do I have a pair with my 11? No. Do I have a pair with my 2s? Yeah. So come on over here. And let's say, since I've got a pair of 2s, isn't that really a 2 squared? Because there's 2 of them? Yeah. So I'm going to go ahead and say I've got a square root. Remember, it's the square root of 88, so it's still square root over here. Do I have another pair of my 2s? No. So what I've seen some students do is, once they've identified that they've already used the pair, is that they lightly cross it off so they don't accidentally use it again. Because I saw some of you saying, oh yeah, we've got another pair of 2. No, we don't. We just have this other 2, additional 2. So I've got a square root of 2, and I have a square root of 11. All right, maybe you remember, what did I say about the square root and the square? What happens if you have a square root and a square? It cancels out. This was from yesterday's assignment, very particular. So if they cancel out, the square root and the square cancel out, what does this become? Becomes a nice 2. Over here on the right, can I have anything cancel out on this square root of 2? No, because there's not a square. What about the square root of 11? No. So what we're going to do then is really just put it back together. So what's the square root of 2 multiplied by the square root of 11? Well, it's just really just 2 times 11. So what I have is the square root of 22. So if you notice, I have a number outside and I have a number inside. I do not know the square root of 22, but I cannot simplify it anymore because I already broke it up into those primes that we talked about over here. So this is the best that I can do right now. Next week, I'm going to teach you how to find an actual decimal answer that we can use maybe on some word problems, some actual shape problems, and so on. So this is the best that we can do right now. This is the most simplified form. So we start with our factor tree, we look for our pairs, and then we start simplifying. All right, let's try this one. Now, remember, there's a variety of ways to break up your number into your factors. So if you don't choose the one that I choose, that's perfectly fine, as long as you get the same circled primes that I do. Whenever it ends in 0, what number do you think I want to use? A 10. So I would say 10 multiplied by 12 is 120. Are either of these primes? No, so that means I cannot circle them. So I'm going to go ahead and break up my 10 into additional factors. Again, just like you were supposed to do in 7th grade with prime factorization. So what do I got? 5 and 2, or 2 and 5. The order really doesn't matter. Are those primes? Yeah, so circle both of them. If you haven't done so, go ahead and start to break up your 12 into your factors. Again, remember, you only circle your primes. So this is where some of you might differ from what I would do. Some students would say 2 times 6, or 6 and 2. What's another option for 12, though? 3 and 4. So I'm actually going to choose 3 and 4, but if you chose 2 and 6, that's still good. Only circle your primes, though. Because if you notice, my 4 will give me the 2's that you'll also have. So from a 12, you should have a 3, a 2, and a 2 circled. We got that? Beautiful. All right, let's look for our pairs. No. Yes. The question was, if I do 2 and 6, do I have to break down the 6? And the answer is yes. So you break down the 6 into a 2 and 3. All right, so look for your pairs. Scanning through here. Do we have a pair of 2's? Yeah, so we start off numerically, essentially starting with the smallest number and then progressing up. So it doesn't matter where you take the 2's from. So I'm going to go ahead and say them right here. Do I have another pair of 2's? No, so I got that additional 2 there. Do I have a pair of 3's? No. Do I have a pair of 5's? No. So at the very front again, the square root and the square will cancel each other. So therefore I have a nice 2. And then these additional numbers at the back, the ones that don't have pairs, you really just remultiply them in your head. So 2 times 3 times 5. So what goes inside of the root? 30. Again, this is the most simplified form that I can get right now, so I just stop there. You might end up with a lot of 2's in the front. You might end up with 4, because again, that would be a 2 and a 2, which means there's more pairs of 2's. But again, you just start the process. Factor tree, look for your pairs. All right, 2 more real quick. All right, who knows a way I can break up 54? Because there's a lot of different ways. Nick, what do you got? 27 times 2. Some students may know that one. What's probably more common? 6 and 9. And that's probably what more students would choose. So that's what I'm going to say, 6 and 9. But if you wanted to use 2 and 27, that's definitely doable. Okay, I cannot circle 6 or 9 because, again, those are not prime numbers. Does anybody know what the other term is if it's not prime? It's a composite number, which means you have more factors involved. So let's go ahead and break them up. So 6 again is 2 and 3 or 3 and 2. Circle your primes. My 9 is 3 and 3. Primes are done. All right, start by looking again for your pairs. Do I have any pairs of 2s? No. Do I have any pairs of 3s? Yes. So I'm going to go ahead and write it as the pair, which is 3 squared. I'm going to lightly cross off the pair that I just used. Do I have any more pairs? No. So I really have a remaining 2 and a remaining 3. So the 2 is kind of the loner. This other 3 is kind of like that third wheel when you hang out with the friends who are dating and you're all awkward standing near them. Some of you know what that is. All right, so what happens here at the beginning? The square root and the square cancel each other. So I write a 3. Square root symbol. Put them back together with basic multiplication. So we've got a nice 6. So again, you're going to have a number in the front, a number inside. The number inside is the most simplified form that I can get for my root. So again, 3 multiplied by the square root of 6. I really don't know what the square root of 6 is yet, so I'm just simplifying it the best that I can. Again, next week we will get a decimal answer. All right, one last one together, and then you'll get time for your homework. All right, let me get you started. All right, some of you look like you had trouble starting, so one way that you can do it is if it's an even number, you could always say 2. Now, if you don't know what the division is in your head, maybe you have to go to the side and actually divide by 2. But if it's an even, always 2. If it's an odd, try a 3. It may not work, but at least it's a strategy. If it ends in a 5, you could always start with a 5. If it ends with the 0, you would always start with the 10. So some little tricks to help you get started, because again, I saw some of you just sitting there. I'm sure you're willing to go to the side and do your division. All right, so who has it? 2 and... What's that? Too small. 60. There you go, 66. Oh, I'm sorry. So I was just talking about those two factors, 2 and 66. All right. Then I've got 6 and 11. Circle 11. Then 6 is going to be 2 and 3. Again, same skills from last year. Question is, can I do 33 and 2? So it would have been like this. You'd have circled the 2. 33 would be 3 and 11. So it's a 2, 3, 11. I have a 2, 3, 11. So yeah, it is available. So that's why I'm saying that some of your work might differ than mine, but your primes should be the exact same primes that I get. All right, great questions. All right, going to the side, looking for any pairs. You notice we have a pair of 2s. No pairs of 3s. No pair of 11. So square root and square cancel out. So I've got 2. And then sometimes in high school, instead of root, you're going to hear the word radical. Radical 33. Again, your upper level math in 9th grade, 10th grade, and then beyond, it might be called radicals. But in 8th grade, we just call them roots. So 2 multiplied by the square root of 33. Again, we don't know what the square root of 33 is, but it is the most simplified form that we're going to learn to use. And then later on, we'll learn how to do a decimal. This is actually easier work here than trying to find the decimal answer. That's why we start with it. All right, any questions? We good? Say with me. Be awesome. There we go. All right, thank you very much.